Bismillahirrahmanirrahim. Assalamu alaikum everyone. Welcome back to 3673 Ecological Building Design and Materials. Today we'll be discussing the unit number 6, that is energy from the sun. Sun is one of the major sources of energy which we have naturally. Provides almost all of the world's energy needs: warmth, wind, rain, and photosynthesis. An unimaginable wealth of energy falls on the Earth's surface, dwarfing human fossil fuel use, all right, which is very small as compared to the energy which is falling on the Earth's surface. After providing for life on Earth, most of this energy is converted into heat radiation, which disappears back into the space, which is not trapped over here until and unless we have a higher concentration of carbon dioxide or global greenhouse gases. Without that, most of it disappears back into the space. Now, this renewable energy generation system was in perfect balance for millennium. That means millions of years until we overuse the capital stores of fossil fuel. That means we use gas, we use petrol, we use diesels. And because of these usage or burning of the fossil fuel and discovered the greenhouse gas effect. That means high concentration of water vapor, carbon dioxide, and some other greenhouse gases like methane. Once they have accumulated in our atmosphere, they will going to retain most of the heat over here, which results into global warming. So if we are to minimize our fossil fuel and increase our reliance on solar energy, we need to understand how it works. So this is a basic diagram in which solar radiation, as you can see on the left hand side, top side, the solar radiation is 173,000 into 10 raised to power 12 watts is directly coming. So direct reflectance is 30%, which goes back in the short wavelength form right after touching the atmospheric zone, जो cover है हमारा. And then the conversion to heat is almost like 47% is gone back. Remaining is over here that we are going to get, which is comparatively very less. So rain and snow, it also revert back some of it like 23%, 47%, 30%. Wind and waves, convection and currents uses like almost 0.002%. Photosynthesis uses some amount of it. And finally, we are going to get some it. So as you can see, there is a lot of long wave and short wave radiation which is going back, but the one which is reaching the surface is the one which we are using, and through that we are trying to utilize and retain life on the surface of the earth. And there are some other fossil fuel based generation जो कि यहाँ से, as you can see over here, is there, the nuclear, thermal and gravity geothermal के form के अंदर ये वाली आ रही हैं, and then those are also emitted back. As you can see in this diagram, this is how the different seasons are going to have the solar path. We have, like in the summer, it's a longer day. We have got the summer solstice, which is in the June, in equinox in September and March, and it's winter, it's the solar, it's the winter or the small size solstice, which is mostly in the December. So when you see this thing, we have shorter days and our angle is comparatively at a lower angle. As you can see over here, this is somewhere in between and this is the longest. So when we have the longest day, that means the solar angle will be comparatively at a steep angle, like close to 90 degrees. Whereas in the winters, it is close to comparatively a lesser degree, like in 70s and 60s, and they change. So when we talk of radiation or directly, some of it is diffused radiation and some of it is direct radiation. This is the summer radiation and this is the winter radiation. As a lesser angle, as you can see, and can penetrate inside. Whereas when we have the shading devices, as we have already studied, it is going to block that direct exposure inside the spaces. Then we have got some reflection from here and some diffuse radiation. When we have cloud cover, we don't get the direct sunlight, but we are going to have diffuse sunlight. So when we talk of the solar geometry, the apparent part of the sun through the sky has two variables, which are brought about by the Earth's spin and its journey around the sun. So that means one path is around the sun and the other is against the axis on which the Earth is spinning. So Earth's axis of rotation is inclined at 23.5 degrees to its solar radiation or solar rotation axis. So we experience a change of sun angle during the year depending on our latitude. Anywhere in the world, the sun angle at noon in midsummer compared to the midwinter will vary by twice of 23.5 degrees. That is almost 47 degrees. Of course, at the equator, A difference of 23.5 degree either side of the straight overhead is hardly noticeable, whereas at the Arctic Circle or at the top north and southern zones, sun angle varies between 47 degrees and 0 degrees above the horizon. That means, very simply, that the areas which are at the steeper end are going to have longer days and longer nights, or even some of the areas are going to have like 6 days and 6 months days and a 6 months night, because of the axis of the 23.5 degree rotation of the earth on its axis along its rotation along the path around the sun. So Britain lies between latitudes 50 degree and 59 degree north. If we take 52 degree as an example, the sun will be at a maximum horizon angle of about 62. That is with reference to the England. This is very useful information if we wish to collect winter sun into the house and yet keep out the summer sun. This is exactly what we are opting for in our climate or in our context as well. The final important factor is to know the weather conditions, means the small scale or this comparatively like 14 days time frame weather condition, how they are going to be, how cloudy and how dusty it could get above your sight. Excuse me, Ji. So energy arrives in two direct forms, that is direct sunlight and diffuse in the form of illumination through the clouds, as we have seen right over here. This is a direct light and this is the diffuse light. While it's in June, the solar radiation falling on the atmosphere above Scotland is about the same as that above the Gibraltar. The cloudiness of our atmosphere cuts it down to almost two-thirds. That is what is happening in the UK and the Scotland area. So sunshine is directly directional and can be reflected or focused, whereas diffuse radiation comes from the whole hemisphere of the sky. The ratio of these two forms varies throughout the year because of the weather conditions and will determine the angle of any sort of solar collector depending on the job it is trying to do and when the energy it captures is needed. For example, collecting solar energy in the winter requires a collector at a steeper angle as the winter sun is comparatively lower. So a vertical window will do that thing nicely. Lest most solar energy is available during the summer, a solar water heater will be at a flatter angle in order to be at right angles to the higher summer sun. So we have to see that the collector, whether it be solar panels, whether it be solar geysers or whatever we are trying to avail the solar energy in the form of any collector, it has to be at a specific angle which can facilitate it. It will also pick up diffuse radiation, better at approximately 30 degrees from horizontal, which conveniently is around the average roof pitch in the UK. So as we have already discussed in 3672, this is the climatic configurations or different forms of climate. And as you can see, Pakistan lies in more like arid and humid continental zones and some humid subtropical zones as well. And as we are very close to the equator over here, so we are going to have much of the time will be in a hotter zone. So when we talk of the shift of the seasons, as we have already discussed, the Earth is not, this is the axis as you can see, this is the axis 23.5 degrees from the main axis around which the Earth is rotating around the Sun. So over here, as you can see, we are going to have summer on this end, whereas winter on that end, because this is going to have more sun. And over here, the summer will be on that end and winter will be on this end. So in this way, the autumn and the spring and the summer and the winters are changing. And all temperate climate experiences a seasonal shift. The external temperature lags behind the solar seasons because of the time it takes to heat up and cool down water and earth. The solar midsummer, the 22nd of the June, occurs some months before our warmest period, usually in the August. March 22nd has the same amount of sun as September 22nd, but is far colder comparatively. So these are the three different ways in which the radiation works. The first one is convection. Heat comes, convection removes heat from the glasses, which is like 87% is reverted back. Light reflected off the glass. Then we are going to have some heat radiation from the glass which is given also outside, and these surfaces which are going to trap the heat are going to emit the heat as well because of the temperature differences from the outside to the inside where the heat has been trapped. So 87% coming inside, a lot of it is going outside as well. Then when we talk of heat gains, you can use like orientation, glass area, glass typology, thermal mass, internal plan, as well as the passive solar types of different spaces and forms which can be used to gain that. So when we talk of the nature of solar lighting, to get the most out of solar energy devices, be either buildings or solar panels, we have to understand the nature of the sun's radiation. When the sun is overhead, most of the energy is in the wavelength band of the visible light, and not surprisingly, our eyes have adapted to this spectrum. So we can see the reflected bandwidth from different surfaces, which we identify are having different colors. So plants make use of a similar spectrum with a touch more ultraviolet, whereas solar panels can also make use of the invisible infrared energy. At sunrise and sunset, the solar energy has to travel through a much thicker layer of air because the sun is at a comparatively steeper angle as compared to our equator. ठीक है जी. So which contains dust particles. Obviously it has to travel more, so with the dust particles and water vapor that absorb the blue end of the spectrum, giving a red shift to the spectrum. So वो जो dusk और dawn के time के ऊपर, when we see that there is a red band close to the earth's surface, that is because of this, because most of the blue light has been, or the blue spectrum has been absorbed. So when solar radiation hits the surface, so yeah, body most of the visible light energy, the ultraviolet that has got through the ozone layer, and the infrared is turned into heat by exciting the molecules of our skin, whereupon it will be absorbed by the body and give it out again as heat radiations. So over here you can have a look of the solar thermal against the kilowatt per square meters of the micro in the micron form. So वेवलेंथ जैसे जैसे आपकी बढ़ती जा रही है, आपका जो सरफेस एरिया के पर्सपेक्टिव में ये विजिबल लाइट है, दिस इज बिटवीन 0.4 to 0.7. Before that is the ultraviolet, after that is the infrared. So till sunset it's almost like 1.2, and the photovoltaics has the biggest, largest surface area. Visible light and the photosynthesis area is primarily the ones which we use, which with which our eyes have adapted to. So bees can see further down into the infrared, and plants also make use of ultraviolet, and so depending upon how that can be used. And over here, as you can see, transmission of glass jets through about 87% of the solar radiation, but at long wavelengths becomes opaque and absorbs the heat radiation. So as you can see, the the white, this opacity based area, this is a transmission. So a lot of energy spectrum from hot water or wavelength of microns and infrared as can be seen, but longer wavelengths are absorbed and most opaque and absorbs the heat radiation, so they are retained. So the general principles which we have to consider while devising different forms of active or passive mechanisms for extracting energy and optimizing it is basically these three base ones: the collection, heat storage, and heat distribution. They have to be devised in such a way that we can optimize them. So choosing the best orientation and tilt means orientation means how if the device or the house is going to be oriented so that we can maximally use the solar radiation, since most of the Pakistan area is lies in the hotter region. So we try to avoid this thing and we go against this rule to avoid the direct solar exposure. All right. Ji? So however, we can utilize this thing in the south side, west side, we wish to avoid that. uh, the tilt which we are going to use over here either will be for the solar geyser or for the solar panels only. In the northern hemisphere, the greatest quantity of solar energy is received on a south face, assuming it is not shaded by some obstruction. The optimum orientation will depend on the job to be done. If you need a warm conservatory for a pleasant breakfast, then you will face it towards the rising sun in the east, obviously. And if you want to warm the living room for evening activities, then face it on the western side. So from the east towards west via south is the solar path, and we are going to place our basic spaces which are going to be heated up based on the type of space or requirements that we have. So this can better define it that these are the two heating seasons. As you can see on the right hand side, this is the direct and this is the diffuse light. So the direct light gain with the kilowatt hours per day, as you can see, is very high over here. And this is how you can optimize the usage. And as you can see, the horizontal surface, which is close to the equator, is going to have a lot more energy and exposed surface area, lot more higher. The south, east, and west are the ones which are getting the higher one, and the north, because it is going to have diffuse light, is going to have comparatively very less. So we can use shading devices to obstruct, just like we are having shade over here, and we are having on the right hand side picture, as you can see, we are having shade. This shade above the shade is basically because of a tree or somewhere which can be seen, and the glass surface is going to retain the heat. Over here we have got like trellises, so shading devices can be used based on these principles of the orientation to ensure how these can be improved. The second important rule is the heat storage, how you're going to store the heat. The heat storage capacity of the material, the volume of the material available, and how heat gets out, in and out, are the basic principles which have to be devised. And heat storage has two purposes, that is storing surplus energy and avoiding overheating. So when we are going to have overheating, it will be too much humid and too much hot to stay within the enclosed space. So we have to ventilate it. So we have to see what kind of an atmosphere, sorry, not the atmosphere, but the context, the location, as well as the climatic conditions are over there, and how the weather conditions are changing. So we have to see these ones while we are optimizing for the heat storage. Just like this one, they have utilized a Tromivor kind of a thing. So heat storage admittance of selected building materials over a 24-hour period. As you would expect, the dense materials, that means the dense soil, the slate floor, or the dense concrete, or the brick, or render, or the gypsum plaster, they are going to have higher value. The higher the density is, the better it would be. So thermal mass material, rammed earth, as you can see in this picture. Let me zoom it a bit so that it becomes a bit visible. These are the rammed earth, that means a compressed earth blocks की form में, or it can be in the forms of the whole wall has been utilized to retain the heat, and it is going to emit the heat. And as you can see, the skylight has been introduced so that we can have ambient light over here, and the dependence on the artificial lighting is reduced. This is another way of utilizing the same. The floor rubber tiles can be placed, or the wall may have like concrete ones can be utilized, and how the solar gains can be increased. Passive and active solar heating mechanism have to be there. Like when we talk, there are varying number of possible solar heating options, but they are all just different arrangements of these elements. Which elements? The glazing, absorber, heat store, emitter, insulation. And the difference between the various solar heating designs is mainly to do with heat storage. So direct, again, passive solar heating, indirect systems, and isolated systems. There are three different forms which we are going to study over here in the next few slides. But over here, the basic elements are glazing, means how much the glass surface is there, absorber, which surface is going to absorb the heat stored, what is the thermal mass of the place or the surface which is collecting the heat, how much thicker it is, how much condensed it is, which material are we using, is it stone, is it concrete, or is it rammed earth, or is it even water? Emitter, how much part of the heat is to be emitted back into the house to retain that temperature, and to retain that heat as well. And insulation, how we are going to insulate the space so that we do not have like loss of the heat while we are trying to retain it. So these are different forms of direct radiation, indirect conduction, and isolated convections. And through different forms, we'll be exploring them one by one. So over here, as you can see, window and wall type, we are going to have like these kind of formations, direct heat gain, indirect. We can have like a trombe wall, we can have like a water wall based channels, or we can have like stone wall, or can have concrete wall. And isolated convection means the surface is attached and it is emitting directly. In the conservatory, we are going to have like a sun room or a space like that, and with the help of these direct, indirect, and isolations, the surfaces can be utilized to emit the heat inside. Then we have got the roof. Direct gain can the roof can be utilized over here. Over here, we can have like a collector, which is going to absorb and can create kind of a um, convection-based kind of a loop of air movement. Like the hot air is going to rise, the colder one is going to come down, and these kind of things are going to happen, and an ambient temperature can be maintained. And then we have got like the solar panels, which are going to absorb the heat right from here, and they are going to convert it back. Solar geysers can be used, solar panels can be used. So each one of these are explained over here. The direct radiation in detail, direct gain, and the best solar heating over here. As you can see, the surfaces on the walls and the floors are utilizing the direct gain from the glazing. This is one of the examples which has been given in your book by the architects Felton, Clegg, and Bradley. That again, passive solar. This is passive because they are utilizing glass to get the heat directly inside and they are optimizing it. This is an indirect conduction in which one of the surfaces has been introduced indirectly and the glazing is on the outside. This can be utilized just like this one, in which and Trombay by Michael and Trombay is 70% solar heated by the massive wall collector. The climate is ideal for passive solar being sunny during the winter day and very cold at night. The black painted brick wall behind the glazing is designed to store up to a day's worth of solar energy, which conducts through the wall to heat the space behind it in the evening. Then we can have conservatories just like solar rooms. They can retain heat, and once they are, if they are overheated, you can open the side which is facing the exterior. And if they are not overheated and you wish to have like an ambient temperature inside, then you are going to open these windows and they are going to disseminate heat inside, just like this conservatory. And then we are having another example just over here, like a solar room is on this end and it is going to absorb heat. You can see the skylights over here in the roof side. Let me show you these ones. The glass surface is there. As you can see, some of the shades and the shading over here and is visible through the picture. That can be utilized as well. Can be very helpful. Then we can have like glaze street. That is one of our project where you can have like the whole thing covered with the glass, just like an atrium can be utilized for the same purpose if required, just like a conservatory in the isolation form. And then we have got roof in the form of skylights where we can absorb the heat as well as the light can be brought in. And then we have some other, these were all passive mechanisms. So now we are going to explore a bit of the active solar space heating mechanisms. Excuse me, White, apart from the whether they save energy, many passive solar options are worth installing simply because they improve the quality. So once they are able to improve the quality, or where you think that the passive mechanism is not good enough to provide a comfort zone, we have to go for a hybrid one where the active solar systems have also to be induced. This over here, as you can see, a climate solar water heater which is over there, and the piping mechanism could be utilized. This is just like a solar geyser. It can be utilized. Then we can have like preheat cylinder or thermosiphon gravity system based thing, in which these surfaces are on the outer side and expansion tanks are over there, and we are going to have like preheat cylinders where the heat or some alternate mechanism could be used over here. As you can see, we have got the solar collector. So it is going to heat it up and the heated surface is going to be sent back. The colder one will be brought in, and once they are going to heat up, they will be sent back. Probably you're going to need some kind of a pumping mechanism to do that. This is another way of doing the same way. Over here is a pump system where the pump is going to force the water to go upside, and over here the gravity can brought it back. This is another one diagram of a close coupled solar water heater system, just like this one over here, where the surface areas and these channels are introduced, and with the help of these, they can be moved backward and forward. So utilizing these kind of forms and surfaces, it is baseline that these can be uh, transformed and can be utilized. Just like these surfaces are over there, as you can see in the left ones, they are going to have like darker surfaces so that they can absorb maximum of heat and they can be utilized in a combination. So this is more or less of your lecture, G. The whole house book, the reference by the Cindy Harris and Pat Border. I would request you to kindly go through the slides. I'll request you also to go through the video. Ensure that you are available in the LMS sessions, and we are going to have discussion back over there. Thank you, everyone. Take care, Ji. Allah Hafiz.